So we're going to solve this quadratic equation by completing the square. So as I just mentioned here, we can't solve by factoring this because there's no two numbers that multiply to 4 and add to 10, right? We've got 2 and 2, we've got 4 and 1. So none of those combine to 10. So we're going to complete the square and solve. So we remember how to complete the square here. We've got x squared plus 10x. We're going to group those two terms together, and I'm going to add a third term to make a perfect square trinomial. I'm going to put that in brackets like we usually do. I've got this 4 over here, and because I'm going to add something in here, I need to subtract the exact same thing to maintain this equality. So that's where we're at in our first step, and I would encourage you to map this out with the plus blank and minus blank and all that stuff. I think it makes it real easy. So what number goes in here to make this a perfect square? Well, we look at the b term, we divide it by 2, that gives us 5, and then we square 5, and that gives us this term. So this should be 25. So again, take half of this b term, half of it, and square it, and that gets you that term there. Half the b squared. So once we've done this, we've actually added 25 to this side of the equation, so now I need to subtract 25 to maintain this equality. So still equal. It looks quite different, but it's still the exact same quadratic. It's just I'm showing different parts of this now. We're kind of revealing different parts that we didn't see before, right? But it's still the exact same equation. So now I'm going to rewrite this in the brackets, okay, as a perfect square. So it's going to be x plus, and it's whatever the half of this one was that we squared. That's what goes in here. X plus 5, all squared. Okay. What's 4 minus 25? Well, that's going to be negative 21 equals 0. So up to this point, we've been able to complete the square. Now we realize that this is an equation, and I need to solve. So I need to solve for x. And do you know what? The real reason why this is actually pretty handy, this completing the square, is because of this. Before, when we first started, the x's were in two separate, unlike terms. So you could not isolate for x all by itself, because it was in two different places, in two different terms that could never come together to be combined. But now, x is only in one place. You see? X is not in more than one term. So I can now isolate for x really easily. So what I'm going to do is I'm going to get the 21. I'm going to add 21 to both sides. And I'm going to rewrite this as x plus 5 squared equals positive 21. Okay? I'm going to pause right here. I'm not sure if this is something I've talked about yet. But please note, at this point in your solution, okay, if you have something squared and this equals a negative number, okay, if you ever run across that, that should send up red flags in your mind. And if this is a negative value over here after you've squared something, then there's no solution, because that algebraically doesn't work. And why wouldn't that work? Because you'd have to take the square root of a negative number. So that's not the case here, but if you have a negative over here and you have to take the square root of a negative, that's your red flag that there is no real solution, okay? Just a note. Can't take a square root of a negative ever. All right, so, but we can now take the square root of both sides to get rid of this squared. So this becomes just regular old x plus 5. And 21 is not a perfect square, so I can't reduce this down to a nice whole number, but I can rewrite it as root 21, which is what you should do. And remember, when you take the square root of a number, you have to include plus or minus. Okay? Now, why am I not writing this as a decimal? Because the question says express your answer as exact roots. So exact means we do not convert on our calculator to a decimal and round that decimal. That becomes an approximate answer. So I'm going to leave that root 21 in there. Not quite done yet. We're going to keep going. I'm going to subtract 5 from both sides so that I have this. We have to understand this as two separate answers now. So I'm going to rewrite them separately. The positive version of this root would be positive root 21 minus 5. And the negative version of this root would be negative root 21 minus 5. Okay? And because we can't simplify those anymore, those should be our answers. Okay? So before, when you looked at this trinomial and said, oh, I can't factor it, there might not be any, probably not any solutions. Well, there are actually solutions. And now we found them, and we found the exact values of them. Okay? So let me just zoom out so you can see the whole thing there. So that's number 6A. I would encourage you now, I want you guys to try 6B. Okay? So try 6B on your own, and then I'll show you the answer in a minute. I'm going to erase this, so make sure you've got this copied down. But try 6B now on your own, and let's see if we can get the same answer. All right, so here's my solution for B. Now, in the first example, what I did was I completed this square and I subtracted the same amount that I added on the same side. But I thought this time I'd just show you that you can move this 13 to the other side right away. And if you're adding something on one side of the equation, you can add the same thing on the other side. So that's just a slightly different method. What we're going to end up getting is a completed square here. X minus 4 all squared equals, and then the sum of these two would be 3. Taking the square root of both sides now to liberate the x from this squared term. Square root of something squared, they just cancel each other out. I have x minus 4 equals plus or minus root 3. One more step to solve for x, add 4 to both sides. And it's okay if you express your answers. You have to understand that there's two separate answers, but if you express your answer like this, I'm going to be fine with that. Or if you did 4, it also, I guess, could be x equals 4 plus or minus root 3. That's okay as well. And I believe that's what the back of the book says, gives for their answer. I need you to understand, though, that these are two separate answers. The positive root 3 plus 4 and the negative root 3 plus 4. Two separate answers there. Okay, any questions about that? Okay, so here's your assignments, and then just a reminder too that there's these videos on MrMathWell.com that you can watch from previous classes if you want some more practice on factoring, for example, and I'll post your homework up for today.